Hi, welcome to my channel. As I promised, I'm going to share the complete playlist on design patterns with in detail explanation, and this is like factory design pattern. So my way of explanation is a bit different. I just generally don't explain example or straight away some kind of theory. First, I'll explain like why we are choosing factory design pattern, what is the existing problem, how factory design pattern is solving, and standard definition and class diagram, and finally with Java examples. So first, think about how we will generally create an objects for a class. Think about this one. So we have resource 1, resource 2, and resource 3. These are like three different classes, and we want to create an object for each class. How we generally do? We'll straight. We have three resources: resource 1, resource 2, and resource 3. So now we have a driver class is there. Now we want to create a class for each one. Generally, what we will do, we just create either like traditional way of creating objects for each class. So there are three classes are there. We are creating three different objects for each class. So and we will access accordingly like each methods inside the class. Now let's say we are going one step ahead. So this part we understand like how we are creating object. Next we need to focus on like how we will create an object when multiple classes have similar use case. Let's say resource 1 is there. Resource 1 is basically have like same function called get resource, and resource 2 is also have a single function called get resource. Resource 3 also has same function called get resource. Then what you will do generally, if you are good with Java programming, then you definitely know there is a concept called interface. You create a common interface, and you'll write a abstract method over there, and rest of the classes which has basically common, they it can be any number of classes that simply implements that particular interface and implements the all the abstract methods. So that is the second way of doing second way of creating an object. So now you have an interface and you have three different classes. So in the when you're writing a logic in a driver class, how you generate it? Interface like object name equals to you're creating whichever a class you want to create an object equals to new class object, new class. So likewise you are creating like different way of creating objects with the help of interfaces. So okay, but these two are absolutely a good way. Like now, before talking about factory pattern, let's think about like why factory pattern came into picture. Like so, because as we already see, like our problem is getting solved because of the single interface. With it doesn't matter how many number of classes are there. Whoever wants to implement that particular class, particular interface, there is a we can easily implement, right? Now let's talk about like a simple example with let's say I want to send a notification. So see generally how you will see notifications. Notifications can be either through SMS, through email, through push notifications if you're using apps. In all three things, notification is like send notification is common. There is like common set of attributes also there. For example, it might already define like from and to. For example, it comes to SMS, it will be like from is a number and to is also a number, and there is a subject is there. It can be, let's say you are sending an OTP, so then the subject will be the OTP number with a certain validated how many minutes it was validated. It will be validated. So for example, let's say it is like email notification, then there also from and to is common. Like here in the case from is a mail and to is a mail, subject is still common. For example, it's app notification, then also the from and to is common, and also there is three certain attributes which is common across like SMS notification, app notification, email notification. So how we will accessing like how we will creating objects. So as we discussed, we have a notification interface is there. In that send notification is common, we create an abstract function So I'm passing a notification attribute, what we call notification attribute class. In the notification attribute class, we have like from, we have to, and we have message. So during push, like in the respect to email notification, push notification, and SMS notification, they simply implement this particular notification interface and overrides the send notification, and they're writing their own logic by sending the basically sending the messages, sending how they want to process from here onwards. But ultimately, both three are like common behavior. So they have extracted a particular function out of like out from three and put it into the notification interface. From there, they are using accordingly, like how they want to return their logic. It's completely up to each class level. So when it comes to driver class, we simply creating an object. Let's say I want to create an SMS notification. So I'm creating a SMS notification object and simply sending the notification. Let's say I want to create a email notification. Here from and to is changed. Here instead of numbers, it will be different from and to. I'm sending the email notification. If you execute the function, right? If you execute the class, it will generally give like SMS sent successfully to this particular to address and email sent successfully to this particular to address. So ultimately the behavior, everything was same exactly. Now let's understand what exactly factory design pattern. So according to the given definition, what exactly factory design pattern in the sense is like define an interface for creating an object, but let subclasses decide which class to instantiate. So this is exactly what we just discussed, but there is one extra layer which is added called factory class, that is actually creating an object for us. We are not concerning about creating an object in the driver program. So we will ask the factory class, okay factory class, I just want to create an object for the SMS. Okay factory class, I just want to create an object for let's say phone, let's say email. So factory class, which is responsible of creating an object of the particular query, whatever we asked, and then returning back the object instance. And let driver class implements or access the methods of the particular class accordingly. Like, so we can also call the factory class as a virtual constructor. Why we call factory class as virtual constructor? Because factory class is basically access. From the help of factory class, we are able to creating an object, but internally it was creating each class constructors only, but we are actually creating an object, right? That's why we call it as a factory class as a virtual constructor. So in this example, I'm going to show you how the notification without pattern can be converted into notification with factory pattern. So this is a simple class diagram which I was drawn. So let's say we have an interface called notification, which will send the notification, and it has implemented three things, like three classes: SMS notification, push notification, and email notification. And there is a class called notification factory, and in that there is one method called get instance. That get instance, we are providing notification type. So I want SMS notification. There you can also provide instead of notification type as an enum, you can provide a simply what you call string also. But with the help of notification type as an enum, it makes code very readable, and it is very understand. So there is, and also less number of errors. That's why it is important to write enums whenever you want to in these kind of situations. Like, so I have created an enum called notification type, where I'm passing app, email, and SMS as enums to this get instance. So accordingly, it will either return SMS or push or email notification. See, so this is all about factory pattern. It's a very easy pattern. Let's take about, like, let's see with examples. Let's see the example. So I have a notification interface. So there are three classes which are implements the notification, push notification, SMS notification. Now let's talk about notification type. So this is the enum which has like three things called app, SMS, and email. So for each corresponding class, because this is the passing as a parameter for the notification factory get instance. So now let's talk about notification factory. In this notification factory, we have single public available function called get instance, and here we are passing parameter called notification type. So depending upon the notification type we passes, right, it will return the corresponding object. Because I have created a hash map called factory map. I was in the static block itself, I was initializing all the corresponding objects, all the corresponding class creations for each notification type. So for the factory, let's say if I want to access the app notification type, right, I will return the this notification factory will return the push notification object. Like so here because of like simplicity, I have created like static block. In some cases, let's say static block might not be useful because this is like it will be mostly in compile time. So let's say your email notification is basically taking a parameters like taking a this is basically no-args constructor, right? Which means like all are like no arguments are passing in the constructor. There are few scenarios where you are able to you can pass the constructors, like so depending on the constructors in your fields of classes, there are some setters will be invoked. So there simple like this kind of static block might not be useful for you. There you might create a because this is a one way of implementation, right? There are other ways, like basically in the get instance itself you can write something like a switch case. You can write case by cases, and the email notification you can pass the corresponding hash map or corresponding object, whatever object you want to uses the particular class. So this is all. I think this is the one way of doing. It's completely up to you, depending upon the complexity. This particular factory pattern is like changing, but what is the constant is like driver. For the driver function, for the driver class, whatever complexity of notification factory, it doesn't matter. Like driver function simply asks the particular object, and the factory pattern is responsible if the particular object is presented in our code base, right? The factory pattern needs to be returned. That is the only thing driver wants. Like it doesn't matter how your logic, how you will turn it, completely up to the notification factory, how we generally design. Like so this is all about notification factory, and this is a easy like first factory pattern, first kind of design pattern, and also easy design pattern. Hey, welcome to my second video, creational design patterns, called abstract factory design pattern. In my previous video I have explained like factory design pattern. So in this video I am going to explain like abstract factory design pattern. So first one is like completed. Did you know what factory pattern is like? Yes, that is completed. Factory pattern is basically creating an object in some factory. So let factory is creating an object. So we are simply asking the factory, I just want the object creation of the particular type. The factory class is responsible of returning the particular object. That is basically factory pattern. So we understand how factory pattern creating objects, right? Now I think you know about the concept of abstraction in Java. It's basically what we call abstraction. Hiding as much as possible, it will only show what is generally required. That is called abstraction, right? So what exactly abstract factory pattern? It's like abstraction over multiple factory patterns. Like there can be multiple factory patterns. Let's say factory pattern 1, factory pattern 2, and factory pattern 3. For all these factory patterns, there is a one more factory which is like abstracting all these factories. That's nothing but simply called abstract factory pattern. So let's talk about like by understanding what exactly abstract factory pattern. So this is an abstract factory. So abstract factory has like creating multiple factories. So abstract factory is returning a factory. From that factory we are getting the required object created for us. Like so factory pattern is basically returning the object. So the abstract factory is returning the factory, and we are even calling the function from the factory to get our actual object. So this is a 2-level. Factory is only single level, and abstract factory is like 2-level, like to access the child node. You can say simply in like Day's algorithms. Like so you can simply say abstract factory class basically we call as a grandparent, and factory is like parent, and the class which we want to access is basically children like us. So this is nothing but abstract factory pattern. So let's talk about simple example. So you can read this one. This is not a, see, the definition things are not very useful, right, until unless you know exactly, until unless you understand like what exactly the particular design pattern in the sense. So here I have provided everything in textual format. You can grab, and these PNG files are taken from like different books like Gang of 4 books, Head First Design Patterns books. You can refer those also. So a system should be independent how its products are created, composed and represented. A system should be configured with one of multiple families of products. So you can read all those things. Now let's understand with an example so you get better idea. So if you see this bank, right, bank package, so how the factory will look like. Factory has a single interface, and also all the classes will basically implement the particular interface, and it has like common methods. So and also we are accessing each implemented class through particular enum. So here bank is basically interface. It has a common name called get bank name. So the bank is, so we have like different banks in India, right? HDFC, ICICI and SBI. So all those banks has a common function. Definitely common function will be there called as the get bank name to know about HDFC or ICICI or SBI. So we are implementing the bank interface, and it is returning the we are overriding the get bank name. So it is returning the name of the bank. So we are accessing these three with the help of bank type. So as we exactly discussed how the factory design pattern looks. These are one package. And this particular bank, right? So how the factory should be created with the help of bank factory. So previously, my previous video, I have explained through map, through hash map. So I just thought of explaining through the switch case also. This is like more intuitive. Like you can also use the switch case. So in the switch case, we provided type. So depending upon the case, it will return the corresponding class object. So in the previous video, I have not mentioned about like what will happen if you are passing something which is not presented in the creation part. Then you should simply throw the exception. So throwing the exception is one of the best practices in the in normally Java. So here I was throwing exception called object creation exception. So failed to create an object like. So this is the one. This is the bank factoring. I will explain later how we are implementing all those things. So now let's talk about like loan. Loan is the one more package. Here simply, here we have something called interface called loan. Is one. So every bank. So loan has like different types. Loan can be home loan, personal loan, or educational loan. It can be different types, right? So every type of loan has like interest rate. Is definitely will be there. It's a common function. So we extracted out the common function as an interface, the function as a function. So each corresponding class is basically implementing the loan and overriding the get interest rate and returning the particular interest rate. So education loan has like 6.5 interest rate, and home loan is like 7.5 interest rate, and personal loan is the highest loan of 0.5 interest rate. Now we have like same thing called enum, like loan type, either home loan, personal loan or educational loan. So how we are accessing through factory, we have loan factory. Yes, you got it. So we have switch case is there. Depending upon the what kind of loan, it is returning the corresponding loan object. So if it is loan type is not provided, if it is loan type is not there, we are simply returning like an exception called object creation exception. So now these are the two different factories which are like completely not related to each other. Now we are providing abstraction over there. Like let's see, when we are providing abstraction, so there is generally 3 and 3, and each one. So there is a like in a bank called let's say HDFC. HDFC can provide like personal loan. HDFC can provide like educational loan. HDFC can provide like other types of loans. So which means like with the help of abstraction factory pattern, once we get the factory pattern, we can access the we can even pass the particular object to the other factory to get the loan of how HDFC is providing. So for now it is out of the scope. So let's talk about like how we are creating an abstract factory pattern, and then accessing the factories, and then child classes. So we have, so for abstract factory pattern also there is simple way. Create an interface called abstract factoring. Here I was using the generics. So why I am using generics? Because one should be return type, which is definitely an interface called interface, either bank or loan, that factory return type. And third thing is like each factory is basically takes the argument, right? That's why I have created two generics. So one to return the particular object, and second thing is like what is the argument we are passing. It's completely how you design your abstract factory pattern. So, and we have something. So we have how many factories are there? Two factories, right? So in the object type, again we have declared an enum just for readability purpose. So one object is like bank, and second object is like basically loan. Now let's come over like our main class called abstract factory provider. In this abstract factory provider, there is one. See, I already told, right? Grandparent, parent, and child. Abstract factory, and class, right? So the abstract factory is basically returning the factory. So abstract factory dot get factory is returning the factory, and that bank factory we are getting the any like either HDFC, ICICI, or SBI. So here we are passing the object type. If it is bank, it is returning the bank factory. So if it is loan, it is returning the loan factory. If you are not there, we are simply throwing the error. Now let's see how driver program looks like. So in the abstract factory, we are passing the bank as a return type and bank type as an argument. So while during creation call, right, we can simply with the help of these two we can get. So we have an abstract factory provider dot get factory. We are passing the object type called bank. So abstract factory provider dot get factory is basically returning the bank type abstract factory. You can simply call the bank type abstract factory. From the bank type abstract factory, we need to create an object, right, of the particular bank. We got a bank factory. From the bank factory, we need to create an object of whatever bank we want, like. So here this two is basically called as like factory. These three is basically called as like abstract factory. Similarly for loans, so here this is like basically returning the loan factory. Here we are creating the loan factory. Here we are creating the object for loan factory. So if we run, here we simply get like bank HDFC, right? Bank name is HDFC. Interest rate is like personal loan. It can be 10.5 something, right? So here if you see HDFC personal loan is 10.5. So this is the way of you writing the abstract factory pattern. If you know about how to design a factory pattern, abstract factory pattern is very easy. Like it's like parent of factory pattern. So that's it. Like this is like a very easy way. I hope you understand this one. If you didn't understand anything, please put your views in comment section. I'll try to reply to every comment. This is a video on like creational design patterns. Builder design pattern. This is basically one of the most used and most important design pattern, and for Spring it's like by default design pattern. Like so with the help of builder annotation, you get complete implementation just like that, like in the Spring Boot. Like so let's talk about like builder design pattern. So before that, we need to know how to approach think to get to builder design pattern. So let's talk about like how we generally create a constructor. Like what are the possible ways of creating a constructor? So constructor can be created with the help of new statement, right? Constructor. So what are types of ways of constructor? It can be like no-args constructor, and also we'll pass arguments in the constructor. So these are the different ways of creating a constructor. Like let's say if a class has like 50 fields, and like now I want to create an object and initialize all those fields. Now how you will create a constructor? Like let's say it is not a good practice of passing all the variables, all the 50 variables in a constructor, right, as a functional arguments. That is a very bad way of designing things. So because all those 50 fields might not be useful, some can be null. So you need to pass everywhere. Like when you're creating a new object, let's say you're using a class in a 5 different ways. So one way, for one type, making only 10 fields and rest of the fields as like null. For other class object, for other type of initialization, you are making around 30 fields as like your passing parameters and remaining fields are null. So seeing lot of unusual things and passing as an arguments in a constructor, which is very bad way of designing things. So you can use setters and getters. There is another way of designing building things which very good way, I would say. So before going to that, let's think about like how we create a user details. What are things are required? Let's think about like I want to store a user info in our DB. Let's think what all things required for me. Like, so for me, what is the most thing required is like username, your password, and also email ID. What else things can be there in the user database? It can be phone number, date of birth, first name, last name, middle name. It can be anything, right? So we already got a lot of things, like when using login, when using sign up, we are using user object. Everything we cannot be displayed, like, so some might be null. So there we will use like a different request mapper, response mapper might be different, but in general way, for some cases some might be null, for some cases some might be required, for some cases complete whole object will be required. So that's why we require some kind of building mechanism where we can require as many fields we want, and we can ignore remaining fields or whatever fields we don't want. That's nothing but a builder pattern. Let's see builder pattern. So builder patterns basically talks about separating the construction of complex object, just now what we talked, from its representation, so that some construction process can create different representations. That's what I just told, right? Depending upon whatever we want, we just build only those things. It gives a different behavior every time we are constructing, but that doesn't looks very complex. It's like it looks very simple. We're building what we actually require and we're ignoring rest. That's actually builder design pattern. Now let's talk about examples. Like builder design pattern is most used and well known in Java, and yeah, whenever it's required whenever your class is basically configuration class, when you want to configure lot of complex objects from the particular class, their builder pattern is like very useful. Not just useful, people will only use the builder pattern only. There are three major issues with factory and abstract factory design patterns when you're actually creating an object, because we just learned only those two things, right? We are overcoming with the help of builder pattern. So too many arguments to pass a client program to the factory class, that can be error prone, because most of the time the type of arguments are same on the client side. That is the one, as I said, too many arguments. Second thing is like some parameters might be optional, so every time we need to keep as like null. And also object becomes very heavy in the complex stage itself. Like these are like major issues when we are dealing with the creation of object with the help of factory and the abstract factory. So when we create a builder design pattern, when we have too many optional fields, a different way of defining object immutability also, that is a concept we will discuss later. And when we want to restriction over fields, accessing hierarchy, this is the one I didn't see anywhere talking about this particular one, so I'll talk about in this video. So you can actually control the way of building also. See, let's say simple example, you want to build a car, right? You cannot color the car without even have the particle material arranged. So first thing is like you require some engine. On top of that, you will put the what you call machine. On top of that, you will have the color. On top of that, you will attach all necessary stickers and extra design. So while building, this is the hierarchy we should follow. We cannot say okay, I'll first color and then I'll see. It doesn't make sense, right? So this is the way of hierarchy. So we can restrict the how we build the object also. That is the one advantage of using builder pattern also. I will explain both the ways. Now before that, I have explaining this one with the two examples. That's why I already told, right? Sometimes you will require multiple examples to explain the concept. First thing is like with the help of user builder, which I just discussed. Second thing is I'll explain the car builder, how we construct just like that, and how we restrict the hierarchy. Now let's see about like user class. So user has like first name, last name is required in this case, and age and phone number is optional for me. And doesn't matter whether the build, whether it's build or not build. In DB, those two are like basically null fields, and but username, first name and last name is basically not null feature is there in the DB. So likewise also you can correlate with your class with the actual DB. You can basically make both in a sync way, your class object and also how the DB works. So that's why there are gets are there. In user, instead of passing all the arguments, right, I was just passing the user builder. I will talk what about user builder now. So user builder is basically static class inside the user itself. So user builder will have all the fields which has the user object, and also user fields. So there are two mandatory things, right? That's why we'll create a constructor with the two mandatory things, because that behavior is not changed how many times you create the object. But with the optional fields, the behavior will change every time you create it. That is the only difference between mandatory and optional. So that's why I have created a user builder with the two mandatory fields called first name and last name. Second thing is like I'm setting the age. Every time if you observe, right, I am returning the complete object itself, like complete. This is nothing but a the current reference object, right? I am returning every time returning the object. So this is nothing but here user builder. Next set phone. This is also optional, so I am returning this. Finally, we have a method called build that's actually return the user object. So this set age, set phone, all the optional methods will basically return the user builder object. When we are building the object, right? Once the build was done, so user builder should convert into the user. How it will convert? By passing the user builder into the user constructor, so that user will create all the necessary fields. That's why here we are passing this means nothing but we are passing the user builder to the user object. So here in the user builder has the user builder argument in the constructor. It is creating everything like from the builder. This is a simple way of creating an object with the help of builder pattern. Let's see how it works like. So you have a user builder with mandatory and optional fields. So now I just want to build. So there is a form. Let's talk about even more clear. There is a user form is there at the front end side. Your backend logic is there, and there is a data store is there. From the front end logic, you have mentioned first name and last name is like required, and remaining things is optional, which means like after entering the first and last name, if you click on submit, right, it will basically comes to our Java services, and it will directly store in a DB. If it is first name and last name is not presented, then there is front end validation is there. If someone bypasses the front end validation, there is also back end validation is there, because these two arguments are mandatory. Like this is also one concept of how the builder will work. So here I was first checking with the mandatory fields. So I was building like with my name and last name, and was building. So here builder is created successfully. Next time, along with mandatory, I was adding the optionals also. I was entering the age, I was entering the phone. So how this will work is like whenever user updating the form, right, then all the mandatory fields will be pre-populated, and you can enter all the whatever information you want. You're providing to the particular website, right? Like let's say age, phone number. It will build accordingly, and it will create the user object. It will store and it will in DB. This is the way we creating a user object, like with the help of builder design pattern. So only thing you have to put in mind is like basically passing the user builder in the constructor argument instead of passing different fields, different fields of user. Second thing is like create a class called static class called user builder, and there is a one thing called mandatory thing is like whatever fields are mandatory should be as like constructor passing an arguments, and second function mandatory thing is like build object. Remaining things are optional like. So if you execute this program, right, it will return the standard two string whatever I mentioned over here, first name, last name, age and phone. For first example, it will return the null, for phone number and days, it will return. For second example, it will return everything as it is. Like I'll explain. I'll run in very short. So now let's talk about like or else wait a minute. I'll just run and then we can discuss this later. See, if you see, right, see in the first object, like we have first name and last name, and age and phone are like default values. And for second object, we have like we are basically building complete object, right? So we got the complete data. This is about like builder pattern. Let's talk about like priority fields, with priority fields and without priority fields, with the help of example called car. Just now we talked, right? So now talk about without priority fields. So what are the, let's think about fields are required for the car. Like there are so for a car there will be seats are required. How many seats it can be like a small car or big car, right? The seats are mandatory thing, which is a one field. Second thing is like what is the color of the car, and third thing is like what is the engine power. You can add as many fields you want. So for timing I am explaining with these three fields. And also one more thing, I got this question in interview also. That's why I'm explaining particularly this car example. So I just given normally like car builder. So car builder. So I have created getters. So I have created static class car builder. So here nothing was mandatory, everything was optional. Like so I was every time I was returning this, right? So I was returning this. So set number of seats, set engine power, set color. So finally I am building, was passing this car builder inside the car object. So car was created, car object got created. So that is the without priority fields. Now let's say without constructing number of seats, you shouldn't build a engine power field. Without building engine power field, you shouldn't build a color object field. Which means a color has two dependencies and engine has one dependency called seats. So now think about how you will design this one with the help of builder design pattern. Actually, one thing I'm saying is like there is nothing to do. There is nothing. You will change this complete structure. By seeing this one, you might get right. You might just think for a few seconds by pausing this video. If you are good with interfaces, you will. I think by this time you already get the answer, like, because if you see here we are returning this, here we are returning this, here we are returning this, which means we are returning the car builder object. So all these three functions has a car builder object. You can access all these three functions without any hierarchy. Let's suppose instead of you are returning this, let's say you created a interface called seat interface. And then and then whatever interface return type is there, right? If you provided this one, right? Once you build this one, next time when you click on dot, it will give you the function of that particular interface. It will not give you are not returning this object. You are returning what is the return type of the particular function. So it will go to the particular interface, and whatever function is there, it will return that particular interface, like that particular interface function. Anyway, let's see the example, like you might understand very clearly. Like, so this with priority fields, we have a car builder. For example, without setting car, we cannot set engine. We cannot set engine power. Without setting engine power, we cannot set number of seats. Hierarchy is like first we need to set the number of seats. Then you need to set the engine power. At last only you should set the color of the car. This problem can also be called as program to interfaces. So this is the car object, right? So let's see about car builder. So let's see we have like total we have three fields, right? So I'm creating three interfaces, like, so color interface. See, you should understand this one. So ultimately number of seats should return the number of seats should return the engine power object. which means instead of returning this, you need to return the engine power object. This engine power object should return the color object, and at last color object should return the car builder object. That's it, you got it. Means this can be written this, and this can not return this, because this should return the color object and this should return the engine power object. Let's see. We have like first is like number of seats, right? Seat capacity. Seat capacity is an interface which is taking the integer called seat capacity and returning the engine power. So, and engine power is taking the engine power as a argument and returning the color. At last, color is taking the color, which is like last one, and finally returning the color builder. This is the called programming to interfaces. So how the car builder will look like so car builder should implement, of course, should implement all the interfaces, so that you will get all the overridden classes. So when you are implement, because this is, we need to create objects, right? So previously how the builder will look like, how the car builder will look like previously, not this one. Previously car builder, it has like set number of seats, set engine power, set color, and now it was slightly changed to dot seat capacity, dot engine power, and dot color. See, this dot seat capacity is basically returning the engine power. This and this dot engine power is basically returning the color, and this color basically returning the car builder. At last, nothing, we are returning the car with this number of seats, engine power, and also color. Here instead of here we can simply return the car builder also. That is not a big issue. So we are simply constructing the object like so. Actually, you can because of programming to interfaces, right? We are extracting out the static class outside of the car class. If you see, clearly observe, right? So this is the one way of building the builder pattern. So I'll explain through example. Normal car builder. So car builder was builder dot. You can set color at first itself, and then you can decide engine, and then you can decide number of seats. It will simply return the car object. There is no wrong in that. Now let's say this is priority car. This is special type of car. Car builder dot get instance. This get instance is returning the car builder basically, because seating capacity. This get instance should return the seat capacity. First one should be the seat capacity, right? That's why I have mentioned like this. So after get instance, if you see dot nothing was coming, like dot only seating capacity was there, nothing was there. Once you enable the seat capacity, then only you're getting engine power. You're not getting color also, right? Once you're enabling the engine power, then you're getting color. So which means at every level you are basically restricting the way of building the object. It's completely up to your control, like how you want to build the object like. So this is the one way of building the object. You can use in very special cases. Yeah. So I'll run the program. See, both are exactly same, but this is like with priority, with hierarchy restriction, and this is without hierarchy restriction. Anyway, I'll share complete code in the GitHub, right? You can refer also. If you don't know my GitHub, this is my GitHub. Now we discuss about like what is prototype design pattern. It is very easy when compared to other design patterns. So what exactly prototype? So prototype is basically a feature which is already proven. Let's say we have like a model which is already in live, which is created from scratch, and where users are already where let's say it's a kind of machine learning model, right? So that is the first model which they built as we call it as a prototype, like so where they are performing different testing on the model. So a new people came, like new particular group came in the particular organization, and instead of they also wants to design similar kind of model with a more advanced features. Now what they will do basically, they cannot simply create everything from scratch, right? Because it's a waste of time. They simply approach to the particular concern team who already designed the prototype, and they will ask, they will take all the features, and once they have that particular prototype is ready, and from there they will build whatever enhancements and also advancements they want to add in the for the prototype to build some good product. So which means like a prototype is basically taking everything from the existing object and create on top of that. That's simple prototype, right? Now let's talk about like in our programming terms, like let's say why we create the prototype, like because creating construction is very costly. For example, a construction has like very complex object, we need to pass like different classes, and that different classes will call different services, so that it will create a constructor object. Next time if you want to create another object with the same set of variables, instead of calling everything, setting everything, it might not be a good way of doing, right? We can simply ask like a previously created object, hey object, like can I clone your object? Once I clone the object, I have similar kind of properties with like you, so that I can create on top of that. That's nothing but a prototype design pattern. Let's see like example, like design, like general definition, specifying the kind of objects to create using a prototypical instance, and create new objects by copying this prototype. Like as we already discussed, right, we have one object which is nothing but a called prototype object, and all other objects who wants to create similar kind of properties, they'll basically clone the particular object and they'll create. That's basically called as a prototype object. So the concept, things we should take into consideration is like the concept is to copy an existing object rather than creating a new instance from scratch, something that maybe include costly operations. The existing object acts as a prototype and contains the state of the object. The newly created object may change some properties only if required, like for further enhancements, for further advancements. The approach saves costly resources and time, especially when object creation is a heavy process. So these are the basic things which we need to consider when creating a prototype functionality for our particular object. So we can create a prototype with the help of clone method. So before talking about the prototype, let's see how we copy the general objects. Like, so I have created an employee. So simply I am creating another employee too. I am assigning that one. This is really a copying. Let's see with the execution. If you see employee 1 and employee 2, like both employees exactly have same variables. Now someone can say, okay, I copied this object, but there is a one thing you need to understand. Now I'm running the code. Like if both are like if employee 2 successfully copied, right, both hash codes should be different, right? But if you see, both the hash codes are same, it is not actually copied, it is basically referenced. That's why this is not complete way of building prototype. Now let's build our actual prototype. So as we already discussed in the previous slide, prototype object can be built with the help of clone object. This is standard way of cloning something, right? Complete properties. So that's why I have created an interface called prototype, and I am providing a single property called single function called clone, and the return type is also prototype. Like, so I am creating an employee class and implementing the prototype, so that I am required to override the clone object, right? I am overriding the clone object. I am returning the new. So here what should I do? I need to provide whatever till now whatever object was built for the particular employee object, I need to construct here. I need to provide the particular entire object, right? So this is nothing but a simple way of writing a prototype object. So in the driver class, you can simply use the clone method, employee1.clone. Here it was creating a new object. You are typecasting into employee, and now employee 2 can change the behavior if they want, and if they didn't want, they can simply use the same behavior. Now when you are running this program, everything looks exactly same. Now the hash codes are different, like, because both are like two different objects now. Both are like not related to each other. This is the very simple way of like building a prototype object, like. So and among creation design patterns, this is the one way of creating an object from the existing object. Other patterns which we learned previously, like factory pattern, abstract factory pattern, and builder pattern, where we actually creating an object, like. But here is like with the help of already created object, we are taking the properties and we are cloning that one, like, to add extra properties, or like to process the same object. So this is basically called as prototype design pattern. Anyway, I have shared everything in my GitHub repository. In this video, we'll learn about like what is Singleton and different types of Singleton, and what are the Java programs for each type of Singleton with an execution. What exactly Singleton is like? Ensure a class has only one instance. For example, let's talk about like a DB, right? When you're storing a DB, the drivers, it's like basically we need to maintain as a singleton. It should be as a single instance. And also when it comes to Java programming, there are like multiple ways of we are using daily singleton instance, like caching, like logging, like drivers. These all things will be considered as like singletons, like, because their object should be constant, and throughout the application we should access those objects only. Yeah, that's basically called as singleton. There are multiple ways of dealing with singleton. There can be singletons we can design without thread safe, and there can be singletons we can design with thread safe. Because in a real world applications, right, like there are n number of threads accessing our application, like, so we should make sure like those classes which are actually singleton should create only single object, like. So this is like basically small class diagram, like singleton, which has only single, which has like private constructor and only single public method called get instance, that is static, which is basically singleton class object, like. So basically what are the applications when managing the access to resources which share the entire application, and also in real world applications, let's say when we are in PCs, right, generally we are in like hostels. So across the hostel there is basically single what you call washing machine. That washing machine here we call as singleton. So all the people should wash into the same washing machine only, like that's shared across the complete hostel, like. So similarly there is a centralized kitchen is there, that's a singleton. So this is like real world examples of singleton. There are types of singletons are there, like first is like normal singleton, eager singleton, double locking singleton, bill push singleton, static block singleton, and enum based singleton. You can use any of these things. By default, if you're using a Spring Boot application, right, by default every object creation inside the dependence through dependence injection, which is like basically singleton only, like. Now let's talk about like in a sequence way, like normal singleton, which is basically we cannot guarantee singleton is basically thread safe. Let's talk about like how we return like a singleton. This is the singleton as we have standard Java structure. We like singleton class which has a single function called get instance. So singleton called normal singleton, which is like basically has an object and there's a single get instance. We are first checking if object is null, and we are returning we are creating an object and we are returning the object. Let's say there is class A and class B accessing class C. So class C is basically singleton. So class A is basically accessing get instance. Now class A, initially the object is null. We are creating a normal singleton. We are returning the particular object. Next time, let's say class B accessed. So now class B, when we are accessing get instance, by the time object is already created, which is not null, we are simply returning the object. We are not creating the second object. So this is a normal example of singleton, right? Now you understand like what exactly singleton means. There is a flaw in this way of implementation, because let's say class A and class B are accessing like sequentially. That's why the object is created only once, like class A and class B is getting the same object. Let's say there are 10 classes are accessing a singleton object, and all were accessing in a parallel. So by the time of object comes to 10th, right, there might be two different threads might be chances of creating an object like of two different singleton objects. Like it is because this is not thread safe function, right? We cannot guarantee this will become as like a perfect singleton, because two objects can come to here, and two objects, first time it will check, okay, object is null, okay, and thread A comes, thread B comes, thread A checks object is null, and before accessing the 11th statement, right, thread B also checks and still object is null, and both thread A, thread B basically creating a new objects, and it will return the respective objects. It will break the our main goal of like achieving a singleton. So how can we achieve a singleton is like basically with the help of basically synchronized statement. Like let's say if you put just synchronized on top of the function, right? So at a time you can only access only single thread to this complete block. So thread A, like let's say thread A, thread B came here. So thread A is first it will check like whether get instance is free or not. So thread A is basically checks it's free and it will acquire the lock, and thread B will not acquire the lock because thread is already acquired. It will be in waiting state till thread A till thread A release the lock. By this so by this way we can make this as a like singleton, but this is like very costly operation of making synchronize at the functional level, because it will cause the performance performance drawback. Because there are 100 threads are simultaneously accessing the synchronized block. There are 99 threads will go in a waiting state, and then it will it's like basically performance issues, like mentioning the synchronized keyword at the method level. That's why many people will not suggest of using this approach. There is another way of doing this one, is called basically doubly lock singleton, which means like here we are locking only one time, right? Why can't you lock two times? Let's see how we lock here. Like, so in the doubly lock singleton, why I'm mentioning the instance as volatile means because multiple threads keep on accessing this particular instance object, right? It shouldn't get like it should be visible throughout all the threads. For all the threads, it should be single instance. It should not create 100 different objects, 100 different instance with field for 100 different threads. That's why volatility will solve the visibility problem. You used to modify the value of variables by different threads. It means multiple threads can be used in a method and instance of the class at the same time without any problem. That is the main important thing. Now this is like basically here we check the normal singleton at the synchronized keyword at the functional level, right? Here first we checking the if instance equals to null. If it is null, then we are synchronizing only this particular block. We are not synchronizing this entire block, this entire method. This way we can achieve the singleton, but this is also not guaranteed thread safe. Like when two threads T1 and T2 comes to create an instance and execute, if instance equals to null, both threads have identified instance variable to null. Thus assume they must create an instance. They sequentially go to synchronized block and create the instance. At the end, we have two instances. Here, let's say in the line number 20, right? Let's say two threads T1 and T2 basically saw like, okay, this instance is equals to null. So even though we mentioned synchronized at this level, right? So let's say T1 will wait and T1 will basically create here, and it will return. But by the time T2 already waiting at the 21, T2 is not waiting at 20, which means like it is only single checking only. It's like not double checking. It will not guarantee like a single instance will be created. To overcome that one, we will use to create like two way of if condition checks. One is like at line number 30, let's say T1 and T2 came. So at that time both see issue equals to null. So it will go to 31. So 31 for sure, because of synchronized keyword, only one will be entered. So second one won't be entered. It will wait. So for T1 will see instance is still in null position, still in null state. That still is most important here. At 33, T1 is basically T1 is still sees it's a null. So it will create a double like singleton instance. It will return. So then whenever here lock got released, and in the 30 here so 32 line T2 will come. T2 now T2 will check by the time 34 T1 already created an object. Now this will become an object. Now whenever T2 came, now here instance is not null. That's why because of this extra condition, it is not going into this particular block of T2. Even though there are 100 threads are simultaneously accessing, only single one can enter here. It will try to create an instance. By the time it will come out from 36 to 37, we have instance is not null. After coming 37, after coming out to the 36, then only the other thread can only access this particular block. By this way, we can make sure that this particular block will create a single thread. Doesn't matter how many number of instances are there, like how many number of threads are accessing simultaneously. So this is like basically double A lock singleton, mostly used in applications. Yeah, let's see about like we covered like normal singleton and double A locker singleton. Let's talk about eager singleton. Eager singleton is nothing but during compiling the programming itself, we are creating the object. We are not creating an object when we are calling the get instance. By this way, it is guaranteed that only single instance will be created, because by the time of programming ready to execute, it will already has an object in the memory, so that it will simply return the same object. This is like basically costlier operation, because sometimes construction creation might be very costlier, storing everything in the memory. That's why we generally don't prefer the eager singleton. We see drawbacks. Instance is created irrespective of it's required of in runtime or not. We are creating irrespective, but that is not very useful when because of like memory constraints. Like if this instance is not big object and you can live with the being unused, this is the best approach. If this very lightweight, just like empty constructor kind of thing, but this singleton has like 100 fields. It's like very with the single object creation itself, it is basically taking some kind of space, let's say 5 to 6% of space in our complete memory, right? Then this kind of initialization we shouldn't support. Only go to eager initialization when your creation of instance is like very lightweight, when creation of object is like very lightweight. So this is like eager. Next we go to build push singleton. So build push singleton is like similar to of eager initialization, but it's quite different. Until we need an instance, the lazy holder class will not initialize until required, and you can still use other static members of build push singleton class. Here if you see, until unless I call the get instance, this lazy holder is like lazy holder dot instance is not returning anything. Like, so the static block only executing when we are calling the get instance. Until we need an instance, the lazy holder class will not be initializing until required. So this is also very good way of designing singleton, like build push singleton. The person named Bill who found this particular way of designing the singleton. So create a lazy static class and then do the eager initialization. The main singleton will basically call whenever it's required during runtime only. Like this is basically build push singleton. Next is like static block singleton, which we just discussed, right? Like similar to eager singleton only. During compile time itself, we are creating a singleton and we are returning the same instance. Like both, whenever your application is like too lightweighted, right? Your creation of object is not costly, then you can go with this kind of singleton, static or like eager. It's up to you. And the last is like enum based singleton. Enum based singleton is basically enum provide implicit support for thread safety. That's why we shouldn't concern about like thread safety, and only one instance is guaranteed with the help of enum. So mostly in all the gang of books, the best way of implementing a singleton, people will suggest the enum based singleton only. Like in enum based singleton, we have a single enum field called instance, and this is already, so when we can access like enum dot under driver function, we can simply access that one enum dot instance. This is basically creating the instance of enum. You see, this created the enum singleton instance class, right? So this is the way of creating an instance of enum. Like here you can access the methods. So basically people used to choose enum based singleton is the best way of doing one. But let's see how we guarantee like normal singleton versus doubly locked singleton. Because of two locks, right, it is guarantee of a single thing is creating, right? So I have simulated with the help of like executors. These things are not necessary, just for execution purpose I have created. Once we execute it, right, it will create like for normal thread created instance. So these are all like thread hash codes. It was created for doubly lock. These are all like thread hash codes. So it doesn't matter how many times we run. For a doubly lock for singleton, only one instance will be created. For a normal singleton, depends. It might be single. It might be only single instance created, or it might be more than one instance might be created. So you can check like every time running this particular function, because initially I was fixing the threads as like 100 threads, and I was starting like the worker thread. So I have created two runnables like so here if you see, right, here if you see three objects are created for if you're using normal singleton. That's why I said normal singleton is like not thread safe, like. Whereas if you see the doubly lock singleton, right, anytime it doesn't matter, only one instance will be created. That is the main difference between the doubly lock singleton and singleton, because with the help of single if condition we cannot guarantee that is thread safe. Here if you see, three different instances are created here. How I'm simulating here is like basically I'm creating two runnables. I'm implementing runnable. I'm overriding the run method, and every time I was getting the instance of, first time getting the instance, I was printing the hash code. Second time if I get the instance, right, it should return the same instance, but because of this is non-thread safe, it is not returning the same instance. Other thread also accessing, because every time I was running everything in a parallelly, like because of this for loop, right, I was executing this worker in a parallelly. Execute the given command at some time in the future. The command may execute it in a new thread in a pool thread. So I have created anyway 100 threads. So that's why any one thread can pick up to do this task. After that one, I was waiting till it becomes shut down. So this is the example of how I'm shutting down. Once I shut down, I was starting the other doubly lock. So doubly lock also I'm doing same thing. I was creating doubly lock runnable. I've created a class called doubly lock singleton and implements the runnable interface and overrides the run method. And here I was calling the doubly lock singleton. Because of I am using doubly lock singleton, it is guaranteeing that only single instance is created. If you see, no hash code is not changed at any time, even though I am creating 100 threads. But whereas a single thread, sometimes hash code is changing and sometimes hash codes are constant. Only one thread object is created, but sometimes there are like three objects are created. That's why people mostly prefer using doubly lock singleton. But generally, like in the among gang of design patterns everywhere, if it is like if your singleton, if your object is very lightweight, then go with the eager singleton, or like what you call like static block singleton. But among all the singletons available over here, right, the best thread safety. So by this way, I think you can create like this is the way of singleton, how singleton works. Today I'm starting like structural design patterns. So now let's talk about like adapted design pattern. That is the first design pattern among structural design patterns. Now before going to adapted design pattern, let's talk about like some small problem. This is the problem commonly occurs in when we are in railway stations or like when we are in airports, like. So where they basically wants to charge your mobile with the help of charging pin, and you'll go near the charging port. Suddenly you'll feel different kind of behavior. What is the behavior? Like your charging pin might not be fit into the particular charging port. Why? Because both are like two different configurations. So what you will do in this case, like the first thing is like you will check for alternatives. Like you will ask like all the persons who are like sitting around that particular charging port and ask like, hey people, I have my charger has this configuration and the charging port looks like different configuration. Did anyone have like a adapter or a converter which acts as a middle person, so that I can put my charging pin into the particular adapter, and I can put the adapter into the charging port, so that I can be able to charge. So that is the alternative you will look for. That particular middle object is basically called as adapter. Now let's see the standard definition, and then I'll walk to the Java code. So adapter is a behavioral design pattern that allows objects with incompatible interfaces to collaborate. So these two are incompatible interfaces. Adapter is basically helps to collaborate. So before going to that, I will explain with a small example. So I'm a client. I want to call a request to the particular vendor. You can call it a server also. So I only know JSON, so I serving request in a JSON format. I was posting data, but what happening at vendor side is like vendor only handles XML request. So vendor replies, who are you man? I won't support these. If you again call me, I will block you. Like, so basically what exactly this means, like vendor not able to recognize the what you're asking, like the object whatever you're sending, right? The vendor not able to recognize, like because vendor only able to recognize the XML data, so simply it will reject your request. Now as a problem solver, as a programmer, what you will do, like let's see. So as we are problem solvers, so what if you write a piece of code which will convert JSON to XML, so that I can so I'll write a class where I'll pass the parameter is like basically JSON, and the return type is basically XML. That solves my problem, right? That's nothing but adapter. So here is the improvised code, like improvised version of diagram. Like, so first the client, me calling to the adapter, asks to convert vendor supported format. Like, so adapter basically replies with the vendor supports format. Then client will basically post the data to the vendor. So the vendor, so client, we are posting the XML request. So finally, vendor recognizes our request and reply with the particular response. So this is a small diagram about like how the adapter pattern is work. Among all the structural design patterns, like adapter is something very easy to understand. Let's go through some of the types of adapters, and we can go through a code walkthrough. So adapters are basically two types. One is like class adapter, and second thing is like basically object adapter. Class adapter requires basically inheritance, which doesn't support Java, and also it is against the principle of like composition. So we should use composition over inheritance, right? That's why for now we are using the object adapter. The example which I discussed just now, which is nothing but an object adapter, like. So there are two incompatible objects, XML request and JSON request. We are like we are writing a piece of code to convert each other, like. So yeah, now let's see the code, like. So I have a client. Client is basically calling API to vendor. So client has a JSON object. Client simply serves the request. So client simply serves the request. So I need to write a piece of code that is nothing but adapter. So I have created a class called adapter and implements the client interface, whatever request client is calling, so that client has an argument, right? I can return within a vendor supported return type. So I am taking like a client argument. Now I am converting the client argument JSON object into the XML object. After conversion of XML object, now I am calling to the vendor to serve a request, like. So vendor basically returns the string format, whatever it's so, and if you see client, so client will basically get the data, and we are returning like to other clients who are calling us, like. So if you see the driver code, right? So first we have a client. So client is basically having a constructor of adapter. So adapter in turn has a dependence on a XML vendor. Like, so we are using a client, we are using an adapter dependency, adapter as a composition in the as a client interface here. So this client interface basically responsible to convert into the vendor supported call rate, which means like client should this client interface should has the vendor dependency, like vendor object. If you see the implementation, it has like vendor as a constructor argument. Like, so once we have XML vendor, we can simply return once after conversion of JSON to XML. So if we execute the code, here we are passing the JSON and we are getting the for the vendor we are calling the we are passing as the XML and we are returning the string, and the string we are just printing the response of we are printing the response from after API call successful. If you see, we got the response like vendor call made, and this is the data which we got from API. So this is a small example about like adapter design pattern. So in Java, like adapter design patterns uses very commonly, like in every application. Without vendor pattern, nothing was designed. So let's say we have, you can try this one. I will explain after completion of all the design patterns. At last, when we actually when we are writing big project, like with the help of all by using all design patterns, like. So we have like different kind of data sources, like let's say JPA for relational database, Mongo for NoSQL databases, and Cassandra for it's also kind of NoSQL, right? Like wide column range database. So we have different kind of data sources. Without changing the code itself, like through arguments itself, you can decide. Okay, I want to use the JPA. I want to use the Mongo. You have some particular data. You want to fit the data into either JPA, either Mongo or Cassandra. Here you can use the multiple basically multiple design patterns. Here you can also use adapter. Along with adapter, you can also think about like proxy. You can also think about like strategy design pattern, which I will discuss in future. But you can try if you have time. I think anyway I have shared everything in detail in my GitHub. You can go and watch. You can go and refer the code, everything. Now let's discuss about what is proxy design pattern. So before going to discuss about proxy design pattern, let's discuss what exactly proxy. So proxy is nothing but it's basically someone representing me, like it's an authority to represent someone else. Like let's say I'm representing someone else, like let's say PM Narendra Modi ji. So now I'm basically acting as a proxy. So someone, if you see in politics, right, there is something like acting CM or acting government, like basically proxy in the sense it is authority to represent someone is called a proxy. Now let's see what exactly definition of proxy and also different types of proxy. So proxy comes under behavioral design pattern. You lets you provide a substitute or a placeholder for another object. So a proxy controls access to the original object. You will get to know what exactly control in the sense in when we discuss about like different ways of proxy, allowing you to perform something either before or after the request gets through the original object. Which means like when someone wants to access like original object, so there is a crucial role which is played by proxy either after the request or before the request. So the of the request or before the request can be categorized as like different ways of proxy. Now let's see what exactly there are three ways of proxy. Now we discuss about like remote proxy. Remote proxy, in the name itself it said remote. So our proxy which is there in our network which is connecting to the remote. So whenever client wants to request to the real object which is there over the network, so client is not basically directly requesting to the real object. So if you have a proxy in our address space, now client request will go to the proxy and proxy will basically request to the real object, and then the request, whatever response comes from the real object, right, it will store in the proxy for the next client to serve. So here proxy will basically acting as a middle person between the client and the real object. So a remote proxy represents an object located in different address space, such as a network server. The proxy acts as a representative of the remote object and handles communication. This is the most important one. Handles communication between the local client and the remote object. Now let's discuss about what is virtual proxy. So virtual proxy is a pattern used to preserve memory from being allocated to an object. Let's say, before going to discuss about the complete definition, right, let's understand what is preserving memory, which means like there is a real object which is basically taking like a huge amount of memory when basically during response, like while returning the response to the user, which means like that huge amount of object is basically loading at the client side. So sometimes it is not necessary for the client to see the complete object. Like if client is seeing complete object, it may not be responsiveness depending upon the client bandwidth to the internet, or like client response time might be increases because it should load the complete object, right? So which means that virtual proxy is basically acting as a lightweight to the original object, which is basically heavy memory intensive object. Like, so virtual, let's see the complete definition, you will understand more. So virtual proxy design pattern is used to preserve memory from being allotted to an object that may not be used in the future. Like until the object is not used, a light copy of the object is created, which means if someone exclusively wants to access the original object, then only the original object will be provided, and if not, only light object will be shown. Like, so that's exactly what is virtual proxy. Like, now let's discuss virtual proxy through examples so that you'll get better idea about what exactly virtual proxy. Let's take about example of like let's say Amazon, like, and also for now let's take about Amazon. So we have a client. So client is trying to access a resources like these are like Amazon resources over the cloud. So this is the setup, right? So client basically tries to access the Amazon resources over the cloud. So there are like multiple images presented in the Amazon website. Like let's say it can be through serving through CDNs, or it can be serving through any like whatever options Amazon have. But let's say client wants to see the images. Like, so for example, there might be some high resolution images and there might be some low resolution images. If you the best example we can see is like Netflix. If you watch the videos on Netflix, right, there is like whenever someone uploads the video on Netflix or YouTube in the sense, so what exactly happened when someone let's say we have a YouTube, someone tries to upload something like onto YouTube. So what exactly will happen? So YouTube will basically first of all, YouTube will divide those videos into multiple chunks, and from that multiple chunks, each chunks YouTube basically creates multiple videos again. So this chunk, let's say one video are divided into 6 different chunks. So each chunk again it will divide into like let's say 5. So it means resolutions, like let's say one image can be like let's say 720 pixel image, one image can be 4K, one image can be 1080, one image can be like 240 something, which means what, and also further encoding will be happen like multiple formats also, MP4 or like to support Mac OS, all those things, but that is not what we are discussing here. The main goal is like one single video, and that too only one chunk is basically dividing into multiple resolution videos, which means let's say when I was streaming the YouTube, when I was watching the YouTube video, right, which means there is a possibility that I cannot get the original object, which is basically 4K object. It might not be possible. Whatever the person uploads the video, I may not be see the exact pixel video. I may see the 480 or 240. It will adjust it by YouTube automatically depending upon the my bandwidth, which means those are like basically proxies to the original object. So whenever I requested for the original object, which means I want to see the 4K, whenever I selected that button in the settings tab, right, then only the original object will be loaded. Like otherwise it won't be loaded. Like, so it will only serve through proxy objects, which basically called as low resolution objects. Like, so that is one best example of how images or video compression basically working and also serving to the users. So that is one example. Let's take one more example. So you're basically viewing Amazon reviews. So someone basically reviewed something on Amazon. So you're viewing the reviews and ratings, everything. So if you observe something, if you watch through if you watch on mobile and if you watch on like desktop, there is like different kind of variables will be presented. Let's say if you're watching a desktop, right, you will see full content, you will see rating, you will see image, everything when you're watching on desktop, like or desktop or like laptop or thing. But when you're watching on mobile, which mobile is very small, right, like, so which means you can only see the ratings and only one liner of the, let's say, description. You won't see anything. If you want to see, you need to go there and you are externally asking the Amazon to provide the original object. So in the mobile, you're seeing only the proxy object, not the original object. Like whenever you ask the Amazon, it will provide the original object if you want to see the complete detail of the review. So these will basically categorize as a virtual proxies. Now see the definition. Creating objects on demand, like basically the main idea of virtual proxy is like to preserve memory from being allocated to an object. It can be either through image video compression, it can be either through like what we are viewing into the multiple resolution, multiple screens. So so show minimum required, let's say an Amazon use case, and creating an object on demand, let's say YouTube use case. So acts as a cache layer. Let's say so you like, let's say client, you're accessing something from Amazon, which means like Amazon has like multiple services, right? Amazon is not a single service. So Amazon has like n number of services. So and simultaneously Amazon will basically talk to DBs also, like multiple DBs, which means there are lot of network calls are being happening, like every request you made, there are like n number of network calls happening. So these are all like located in the inside the cloud, right? Whereas let's say when you try to access a request, first it will check whether the resource whatever customer is trying is present inside the memory or not, which means something like cache. It will check, okay, whatever customer is asking is present. It will check whatever customer is asking is presented inside the cache or not, which means so we are maintaining a cache and also what you call tables in sync. So if something is presented in the cache, so we straight away replying to the customer, hey customer, this is your whatever requested, this is your response. If it is not which means here we are preserving the extra network call, because these tables are like basically sits on disk. So which means like you need to basically do the network call, and also you need to find the exact data where actually stored in the disk, and you need to get the data, like, which means like there are a lot of operations involved. Let's say if you store everything in the cache, right, you will save the lot of seconds, like lot of seconds as a responsive time, which is basically improves the user experience. So that's exactly what actually we are saying is acts as a cache layer. So this is basically categorized as virtual proxy, and this is a real object. So I think that's about virtual proxy. We will see the examples. Like now let's discuss about like production proxy. Production proxy is like, let's say you're working in an organization. So this also we can illustrate through example, so which you understand better. Like, so let's say you are in an organization. So you're working on a company laptop. So this is basically company laptop, and your organization basically has some restrictions to access outside internet. Like, so these are all like basically outside internet, these are all basically different outside internet websites. So you need to access all these outside internet websites. So here what exactly will happen? So your company might return some kind of configurations. Okay, whenever person who are in my network, if it is trying to access, let's say this we can call as like Google, and this we can call as like uTorrent, and this we can call as like some XYZ website. So which means, so there is a restriction at your organization side. So which means like so if someone accessing uTorrent, let me block, like, so we are not allowing to access the uTorrent website. So which means whenever you are trying to request the uTorrent, So every outgoing, basically every outgoing network will be basically monitored. Basically, this acts as like a kind of firewall. So every outgoing will be monitored, and if it check, if first it will check in the configuration. Let's say when you're trying to access, first it will check in the configuration. In this configuration, uTorrent is present. If it is uTorrent is present, then straight away this request will be rejected. It won't go. But whenever you're trying for Google, then it will check. Okay, Google is not there. So let's allowing to request through Google. Like, so this is exactly protection proxy. You are protecting your network or your organization from malicious content or malicious websites which are presented outside of your network. Like, so that's exactly protection proxy. So if an application does not have access to some resources, then such proxies will talk to objects in application that have access to that resource, and then get the result back. So when we are accessing over internet for some websites which are malicious are usually blocked in some malls and workspaces. So these we basically call as protection proxy. Let's see the examples of protection proxy and virtual proxy. Now let's see virtual proxy. So I have already discussed the diagrammatical example of like Amazon, right? Let's see the same example. Let's say you have a book. You're seeing all the books in an Amazon. So which means generally book contain name, author is available, and info. Info can be description, everything, right? So let's see the original book, how the original book which is there in the database looked like. So original book has a name, original book has an author, original book has description, rating available. But if you observe here, what do you think? It's like heavy object, which means if you by mistake if you include description also in the response, description can be very large, right? So it might not be very responsive when you're viewing description in the mobile. So this is original book. Whenever someone is asking original book, you can show, but whenever you're asking generally to see the book, you will hide the description. So in the show info detail, in the show info, you're basically showing the complete information of the original book, right? Let's say I have a proxy book also, which also implements the book. But in the show info, I am not showing the complete book info. I'm showing only name, author is available or not. I'm not showing I'm not showing rating. I'm not showing descriptions, anything. I'm not showing anything. I'm just showing only required information. So this can be viewed by any resolution screens. But whenever customers wants to access the original book, we are providing a function called click function. If someone is clicking, so he is basically looking for original complete book information, then we are calling the original book show info method, which means proxy book has like taking a constructor called book. So we needs to pass the original book as a constructor to the proxy book. So we'll generally show the show info of the proxy, but someone wants to show the original book, we'll simply call the proxy book dot click. So let's see the driver code, you will understand even more better. Like, so here a driver, right? So you have an original book. Original book has a complete information along with description also. So I'm a fan of Harry Potter, so I have included Harry Potter first chapter. So I have a Harry Potter book. So now I am proxying the Harry Potter book with my proxy object. So I am proxying this book. So now this is the proxy book. You can even more clear, like let's say you can mention proxy book. So proxy book dot show info. You're just showing only proxy info. Whenever someone tries to show the complete book, you are basically clicking on the proxy book, right? It will display the complete information, like complete book information. So this click basically calls the original object show info, which has a complete toString information. Let's run the program. You will understand even more better. So if you see, right, so proxy book info is basically only Harry Potter, J.K. Rowling, and available is true. But if someone is trying to click the book, we are showing the complete original book, which has like a description, rating, everything. So that is a simple example of difference between proxy book and proxy, and like in a virtual proxy, difference between the light object and also original object, like heavy object. Now let's discuss about what is protection proxy. So I have already showed you like what is protection proxy through diagram, right? Which means we are restricting, which means we have some list is there in an organization. We are basically whatever real internet, whatever request we are passing to real internet, we are basically proxying that. We are basically proxying that one, the complete real internet, and in the proxy internet, we are checking, right? So these URLs are not presented. We'll just pass to the real internet. Otherwise, we will straight away reject the particular request to forbidden, like 403 forbidden or depending upon the custom error configuration. So let's see, we have an internet is there, which will basically, what internet will basically do? It will connect it to the particular URL, whatever we provides. So internet basically implements two things. One is like real internet, which is basically connecting to the service host. One is like proxy internet. Here, if you see, I have properties are there. So I'm basically restricting if someone tries to access the Tamil Rockers, torrent websites, XYZ websites. So these are basically malicious content websites. I need to block if someone tries to access from my network. So basically, so in my proxy internet, I'm basically proxying the internet object. So I'm checking first if banned sites are present. If it is present, I was throwing access denied. If it is not, I was calling the real internet object to connect it to the actual internet. So if you see the driver program, right? Initially, I have a real internet object. I was proxying this real internet object with the proxy internet. Now I have created the proxy internet object. When I was trying to connect to the Google, it will first basically check whether whatever is there in the banned sites or not. If it is there, it will be basically access denied. Otherwise, it will be connected to the real internet here. So let's execute the program. You will better understand. So first one, according to this program, first one should be allowed and second one should be rejected. See, connected to the google.com successfully happened. So and access denied to xyz.com. So this is exactly what protection proxy is. So proxy design pattern is like very easy design pattern, and also many people will use this proxy design pattern in companies or like in organizations. So let's once go through this video again. If you didn't understand, once go through this what you call like this MD file, you will understand even more better. So let's talk about like decorator design pattern. So before going to talk about decorator design pattern, let's talk a few small scenario like let's say, is it possible to divide a number with 0? So generally it won't possible, right? We will throw the exception, like if we write in the code, if someone enters the let's say 2 by 0, we'll basically reply with division by 0 exception. So what is a good way of responding to the user? Like, so there are two ways. First way is basically after entering the user, right, we will run the program. Depending on the program, we'll basically catch the exception and we'll reply to the user like division by 0 exception with please check your denominator. Second way is like, instead of before even talking to our actual function, we will decorating that particular function with the denominator check decoration. In the denominator check, we'll basically checking exclusively whether denominator is 0 or not. If denominator is 0, right, we are not even calling the actual function. We simply straight away return it back to the user saying that please provide non-zero value in the denominator section. Like, so that is nothing but we are basically have the one resource called dividing resource, and we are decorating basically check denominator, so that every time whenever user is performing division, right, so we are checking like if denominator is 0 or 0. If denominator is 0, we straight away are replying to user to provide a non-zero. So this is the one example. I will explain with another example also. Before that, let's see the standard definition. So intent is basically attach additional responsibility to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. So it's basically providing additional responsibility to an object dynamically. That's basically called as like decorator. Like, so this is the basically structure of decorator. I'll explain the structure by seeing my example. Like here I'm implementing the car decorator. Let's say I have a car. So before going to example, right, let's draw the diagram. Like, so you have like basic car, but you just don't want basic car, right? You just want to have like added some luxury, like you are like buy the Lamborghini, which is basically luxury car. So you have added like all the luxury things on top of basic car. and still you are not very satisfied, and again you want even more high decoration. So um, so you even more add some other extra decoration called sports car. Your car shouldn't be luxury, and also your car should look like sports car. So finally you have luxurious sports car. From basic car it will become a luxury car, and it will become a sports car. This is basically called decoration of two level layer. So for some people they just only want sports car, not luxury sports car. For some people they just only want like a luxury car but not luxury sports car like. So we are changing the object behavior dynamically, like we are adding extra responsibility to the basic object dynamically by adding different responsibility, like one is like luxury and second thing is like sports, all those things like. So this is basically called as like decorator, like we are decorating. Now let's see the how I written like. So we have standard car is there. Car basically has one car is interface, which is basically has one function called assemble. So this car is implemented by basic car, luxury car and sports car. So basic car has only basic car implements car, and we are printing like basic car. Now let's talk about like luxury car. Before talking about luxury car and sports car, because these two are like added responsibilities, right? Which means like we need to decorate with the help of car decorator. I have a class called car decorator which basically implements the car, so that before performing car decorator I have the basic car is already created. So I am decorating on top of that either luxury or sports or both luxury and sports. So now let's talk about like so here if you see like here it has a car decorator which implements the car. So here I am passing the constructor called car. Here in the constructor we first will pass the here we can pass either luxury, sports or basic car, and we are assembling, and it will simply call the corresponding car.assemble function. Now let's see the luxury car. Luxury car is basically extending the car decorator. Here we are using the luxury car and we are passing the parameter as car, and we are calling a super car. And every time whenever we are after overriding assemble, right, this luxury car is basically decorating by some other car, right? That's why we need to call the super.assemble. Like it needs to call its parent properties. It needs to get its parent properties, and it will print and it will add the corresponding the particular luxury car properties. Similarly for sports car, same extending the car decorator and simply calling the super.assemble, and here I am passing the constructor as car, and I am passing its parent to the help of super function. Like this super function is basically calling the car decorator. Like now let's see the driver program. Now I have a basic. This is the basic car implementation. Now I was adding to this basic car, I was adding the luxurious car. So first, whenever the luxurious car called, right, this luxurious car takes the argument called basic car. So this is the super of this luxury car. So it will first call the basic car in the assemble function also. It will first call the super.assemble, which is like it will first get the properties of like a basic car properties, and then it will add the luxurious properties, like whatever there in the assembly of luxury. And similarly here if you see this one, right, on top of basic car I was adding sports car, and again I was adding the again I am adding the luxury on top of sports car. This is basically luxurious sports car. If you print this one, what will happen is like, so this is the first one. I think this is a basic car, added feature of luxury car, and added feature of sports car, added feature of luxury car. This is about like a car decorator. Now let's see like how exactly it's working. Like, so it is going to luxury car. Luxury car is basically having the car as an argument. So it is for luxury car, this is basically extending car decorator, right? For this luxury car, the super is basically car decorator. So it is going to the car decorator. So here is basically invoking the constructor, right? Like this dot car. Here the this dot car might be either basic or like sports. So in this driver function, for here it's basic, but for here it's sports. Whenever it goes to sports, again it's calling its parent, that is my car decorator. Again it will go to car. Here by the time here it can be either basic or it can be other extra car if you have there like. So the driver, so likewise it first basically it will first basically build the basic car, then then it will add the sports car, then it will add the luxury car. If you see the hierarchy also, first basic car, then sports car, then luxury car. Similarly you can write for like division by 0 also. So basic car, instead of here will contains like a division, perform division. On top of that you will add like check denominator, is one kind of function. Because check denominator also taking two arguments a and b, and even division function also checks two argument a and b. So you can simply check in the checks division. So we have assemble function is there, right, in the car. Similarly here if we'll call only super.assemble, like say super.division, only when denominator checks is passed. If it is failed, we'll simply straight away written over here like. So that is like you can write your own code. So the main intention is like to explain how exactly decorator pattern works like. So I think this is all about decorator pattern. So we are talking about like bridge design pattern. This is somewhat trickier design pattern and also very easy design pattern to understand with multiple examples. Before going to talk about bridge design pattern, let's what actually bridge means like. So think about a bridge as a way to connect two lands. We have two different lands, and there is a sea is there, and there is a bridge is there, which is basically connecting the two lands. Which means like how we basically construct the bridge, which should be independent of like basically connecting the lands, right? Like the bridge allows people to cross from one land to other, but the design of bridge and the lands can change independently. That is like basically how bridge works. Now let's talk about like standard definition of what exactly bridge design pattern. Decoupling an abstraction from its implementation. I am decoupling an abstraction from its implementation so that two can vary independently, which means like if I mention like a circle, red circle, blue square, blue circle, blue shape, which is like basically these are all like abstractions. I am and this is like implementations. I'm basically decoupling abstractions from its implementation so that I can work on independently. So circle can has red, circle can has blue, square can has red and square can has blue. With a minimum set of subclassing, I can achieve the decoupling of like abstractions from its implementations. So this is the example which I am going to talk about like with the help of coding. If you didn't understand this example, I will talk about later. Let's talk about like very another example which anyone can easily understand, because people love cars, right? So the help of car example you can easily understand. Like let's say I'm the owner of car manufacturing company. So let's talk about like design with examples like. So I'm the owner of car manufacturing company. So I want to design family cars, and also I want to design luxury cars, and there are some crazy people like me who want sports cars, and also I want to design sports car. So if you think about family car, luxury car, sports car, what are the requirements, what all things are included in to design a car? One is like basically engine might be required, and wheels might be required, which are basically not tightly coupled with the particular car. Engines and wheels, these are like basically common properties across cars, which means like those are like my abstractions. I need to take out, let's say we write what are the things are required, like let's say I required wheels, what else I required, let's say I required engine. For now let's say two examples, and these two should be common across family car, luxury car and sports car. So which means like these two are my basically my abstractions. So these three are basically I'm manufacturing, so I need to implement these three to my car manufacturing company, and these three are dependent on wheel and engine. If you didn't perform subclassing, like just how I explained in the first example, you're indirectly making very tight coupling to the implementations and to its abstractions. So we are basically removing all the abstractions and create separately, and making all the implementations let both work separately, and we just use these things whenever it is required. Like, so luxury car contains wheels and luxury car contains engine, family car contains wheels and family car contains engine. So there is a master called car. Basically car is basically implementing luxury car, family car and sports car, and car contains wheels and car contains engine. So you can use like a luxury car with this. So this wheel cannot be single one, right? So let's say something like lightweight wheel, more speed wheel, something like that. Like, so say I'm very bad at like naming, so please bear with me. Like, so this wheel can be different things, and the engine also, let's say engine has like HP engine or different kind of engines. And so wheel is basically we basically extract out the abstractions. So wheel is one kind of abstraction. So, and also wheel has like a list of implementations are there, like lightweight wheel or more speed wheel. So I am using wheel inside my car. So you can basically link your link. So let's say somewhat looks. So yeah, and so if you see like it has luxury car and it has a family car. So basically car has like different implementations called family car, luxury car, and also sports car. And also we are basically extracted out like all the common properties like wheel and engine. Like this way. Similarly for engine also, I'm using the wheel as a composition in the car interface. So I can either use the any kind of wheel I want. Like, so these are like independently working and these are like independently working. Everywhere there is no dependency on that, which means like we successfully decouple the implementations with the abstractions, and we work both are independently. Like changing one might not breaking the other interfaces or abstractions code. That's exactly definition of like car manufacturing company. The company can use the bridge design pattern to separate the engine and wheel components from the actual car design, so that the engine and wheel components are the abstractions and the actual car design, like sports, family or luxury car, is the implementation. This way company can change the engine or wheel components independently without affecting the sports car or family car. So if you have this kind of architecture, you are the marketing in the car manufacturing company. So I have provided like some of the important points to note down. These I have taken from a Gangoff book only. Like, you want to avoid the permanent binding between the abstraction and its implementation. Just now we have checked both the abstraction and implementation should be extensible by subclassing. So should be extensible by both the abstraction and implementation should be extensible by subclassing. Changing the implementation of abstractions, it should not impact the client code, which means it shouldn't be recompiled every time. So all three things we have achieved. Now let's see the sample code. Let's talk about like shape. So shape is an abstraction and color is an interface. So in the example, right, what I have just shown in the example. So shape contains the color. I am making the bridge as a contains keyword. between shape and color. So shape is an abstraction, and shape has like three different shapes: circular shape, rectangular shape, and triangle shape. Here I'm bridging the color. I'm passing the same color in the constructor. Same for interface. Interface has like so interface is basically implementations, right? Like so interface has like some different colors, like black color. So in the driver program, I can use the color to my rectangle. I can use my color to my circle. I can use another color, another property to my circle. I can use the another property of color to my triangle. So these interfaces and abstractions both are like decoupled, and changing the one behavior is not impacting the other behaviors. Like, so this is the way how we should implement the design bridge design pattern. So if you run the program, right, it will exactly prints like this: rectangular painted black, circle painted red. So bridge pattern is a one pattern which you may not get in the first go. You need to rewatch the video multiple times, or you can anyway I have shared this particular MD file in the GitHub, right? You can basically go and rewatch my video, or again you can basically go and rewatch my example also, and also all the information which I provided. Bridge pattern is also one of the important pattern in the structural design patterns, because it's very hard to understand. Like, now let's talk about composite design pattern. Before going into composite design pattern, let's understand how tree data structure will basically look like. So what are the main components in tree data structure? So tree has different set of nodes. Top node will basically called as root, and also there are like children for the root, and children will have subcells. So those children which has subcells will basically called as parents, and those children which are like at the bottom of tree, we don't have any subcells, will basically called as like leaf nodes. So this is the exact same pattern will apply to the composite design pattern also. We'll look in a short time. Like, let's understand the definition of composite design pattern. Composite is a behavioral design pattern that lets you compose objects into tree structure and then work with these structures as if they were individual objects. Which means, let's say we are in an organization where we have like a CEO, and CEO has like direct reportees, and each other reportee has like sub reportees. And finally, there are few people who don't have any reportees. Like, let's say there are like basically level 1 people, software engineers, or like junior design engineers, or like marketing engineers. So when we increase the each level, right, those increasing levels basically called as parent. So in the composite design patterns terms, we'll basically call these four, we'll basically call as like leaf nodes, which is exactly we know, and these four is basically called as parents, right? And in the composite design pattern, we'll basically call as like composite. If you see the class diagram, you'll understand. Like, so we have like leaf and we have a composite class. Both are basically implementing the component interface. So component is an interface which has a common set of operations which has like both leaf node and composite perform. But there are few operations where leaf node cannot be performed. Let's say adding, removing, get child. Let's say I am a software engineer. No one is basically reporting to me. So which means I basically make calling myself as a leaf node. So my manager, he or she is basically composite class. She can add new employees. She can add remove employees. She can get the list of employees. Like, so which means like all the operations which are in component applies to the composite class as my manager. Like, so this is like general class diagram. As we discussed, component declares as an interface, and leaf node is basically leaf represents a leaf object in composition which has no children, and composite defines the behavior for components having children. So yeah, you can go through this particular doc. Let's discuss whatever we have discussed here, right? Let's convert this into Java program. So here I will explain the two ways. One is basically each node I'll make it as like each class, and second thing is like I'll make only one class and one leaf node. Then you can understand difference between both of two. Now let's say I should have a component, right? I declare a component called employee. So employee has like one public function called print employee details. So next thing, let's talk about like composite. So I have like a CEO, which is like composite class, which implements the employee. It can perform add, remove, and also print the employee details. Similarly, CEOs might have product owners also. Product owners also can do add, remove operations. Managers can do add, remove operations. And at last, the leaf nodes here I'm categorizing as developers. I cannot have any add, remove operations. I cannot do anything because I am the leaf node like. So how can we identify like who is manager, who is CEO? Through help of position enum like CEO, product owner, all these things. So if you see into the driver program, basically in this diagram, basically client code. If you see the client code here, initially I was declared two developers called Mark and Elon, and there are two managers, Sundar Pichai and Satya Nadella, and there are two product owners, Bill Gates and Steve Jobs. And there are one CEO, that's of course me. CEO has like all the employees, but CEO's direct report is basically P1 and P2, which means like